I don't know about all of you, but I know that I already want to go do that, and I want to do that, and I want to do that. And so I don't know if you're going to want to do this, but you might find it really interesting nonetheless. Jason, did you need me to wait a second? Oh, okay, we're good to go. So I'm going to be talking about a few things, mostly about the Arctic. But first, what's a Mars analog, following along those themes? It's essentially a location that mimics the features that you would find on Mars. And so similarly, a lunar analog would be one that maps to the moon. And so this is kind of the one of two slides that you'll see on the Mars Desert Research Station, is that this location really looks like Mars. Its geology is amazing, and Utah has amazing national parks. And so being able to live there 4 different times for 2 weeks at a time was a great experience, a great hands-on experience, and something that anyone can do. You can sign up for a crew, you can create your own crew, and these stations are run by the Mars Society. So this is a great way of getting your own experience of living on Mars and working on Mars. So we used MDRS for training to go to the Arctic. Our crew was put together, and we were sent out to Utah, and I kind of went in thinking, you know, if this doesn't work out, I don't know if I can live 4 months with them in the Arctic. And we had a great 2 weeks together. The training we went through was immensely useful. You can see in the top left, we're practicing for a sleep study that we were conducting. The bottom left, we were kind of getting an idea of how we would run our field EVA sessions, because there are polar bears in the Arctic, and you need to have someone who's not part of the crew, but was the polar bear monitor. And so you can see the last person walking here with the shotgun on their back, and usually they were holding it, couldn't really just strap that on. And that was really kind of the only difference between the Arctic and Mars. And so what we learned was that that person in training was following too close, and it kind of took away a bit from the simulation. And so they would kind of hide a little bit and from their vantage point take care of the crew. But one thing to note that people might be like, oh, well, they're not in simulation, but you're almost wearing the exact same amount of equipment as the crew. You're wearing a giant backpack of safety gear. In the Arctic, you're fully bundled up. You're wearing ski goggles and a toque and everything else, so you barely have any skin visible anyway. So it is pretty close, but obviously there's other similarities. Also, we had wildlife survival training while we were there. So where is FMARS, the Flashline Mars Arctic Research Station? It's 75 degrees north. You can see the arrow pointing at it up there. It's on Devon Island in Nunavut. And it's on an impact crater called the Hutton Impact Crater, which is 39 million years old. And the crater itself is analogous to the type of crater that you would explore, in this case for Mars research, but all the work that we were doing up there was the exact same type of work that you would be doing in those locations. And also NASA and the Canadian Space Agency and other agencies sent field groups up there for 1 month maximum during the summer to do the exact same studies we were doing. But the difference being was that, you know, we were using this as an analog environment. So we had a crew of 7. We were there for 4 months, from May through August, made up of Canadians and Americans, and also diverse within that. We had people from Ontario, from Quebec. Within the Americans, we had people from Hawaii, from Texas, and from Arizona. So we had, you know, very different cultures coming together for this. And so while we were up there, we had a lot of constraints that we were observing, and including within that was obviously the remoteness was the key aspect to that. Resolute was the closest city by an hour plane ride. That's if a plane was even available, or if it was even safe to fly a plane. So more than likely, that's your minimum evacuation time. Temperatures were -40. You can pick Celsius or Fahrenheit, it doesn't matter at that point, and trust me, it feels like it doesn't matter at that point. It's very harsh conditions on Mars. Just so you know, the warmest it gets is about 20 degrees Celsius, equatorial during the summer. So it's not as drastic during that time, except for the lack of an atmosphere to warm things up. But we're confined. Every time you would leave the habitat, you would wear a simulated spacesuit, kind of like what you saw Andy's crew in. And another difference here is that there's 24 hours of sunlight during the summer. So that would be very analogous to a polar mission on Moon or Mars. So some more constraints: physical, staying inside the habitat or pressurized tunnels. We had a generator, diesel generator, that we had to maintain, and so we had to fuel that up. The polar bear monitors were part of that exception. Psychologically, 20-minute delay each way. No web surfing. Only specific sites were allowed. We assumed that you could index Google, meaning you could go to the first page of Google, type in your search, and you would see what the current search engine would bring up, and then you would basically have to wait 20 minutes, 40 minutes really, for the communication delay to go to the next level of that web page. We did have a few outreach events because, again, as Tom mentioned, it's really important that we talk to the next generation, and so we had a few Skype calls with a few select schools. We also were required, because we were in the Arctic, to check in with the polar staff that were up there, and we were supported by their safety as well. So we had to check in with them every day, let them know that we were still there and we were still in one piece and not polar bear food. In addition to that, we were writing reports every single night as part of our mission, and that was a status update of how are the HAB systems, how are the crew, but also included all our science reports that were kind of dependent on what we conducted in the field. And you can feel by the air conditioning in the room that it's starting to feel like the Arctic as you watch this. So is this a Mars analog or a Moon analog? And when we first got there, it really felt like the Moon. Everything snow-covered and ice. The sky was hazy most of the time. It wasn't like clear skies all the time. And so you really had that kind of lack of color and depth, making mobility really difficult, trudging through the snow. You can see the pathways from these two crew members. I believe this is one of the first EVAs of being out in the field, just to kind of check out and figuring out how many layers you need to wear underneath even those suits. This is the crater after all the snow is gone, and when it's gone, it's gone. It's a dry desert up in the Arctic. So this is right at the rim of the crater. We were lucky to have a photographer come up there, and you'll see a lot of photos from him in this presentation. So anyway, this is a very barren landscape. If we zoom in a little bit on a section of it, these are some of the hills from the impact breccia that can only be caused from two different things. One from a meteorite collision or from a nuclear blast. So these terrains are, there's not much to them, and there's a lot that we can learn in terms of exploration and safety. This is a little bit of everything in one slide, just to kind of give you a snapshot. I helped run the human factors research projects up there. There were 5 or 6 of them. We're doing everything from an exercise study to a sleep study. We were doing habitability studies, crew dynamics, psychological testing. I love this little cartoon that I found going up to the Arctic, where basically you're playing the role of patient and doctor while you're up there, because we all need to be able to fill multiple roles. And I don't know if you can see in the bottom corner, a little faded out on the screen, but that was probably halfway through the mission. I was just having fun because I was finally shaving. In the middle there, you can see poutine, which is a Quebec delicacy, and that was celebrated for Bastille Day. And as part of our work, this actually became an extra add-on study, a food study, about what we can make and how we could increase enjoyment up in this simulation. Everything that we had to have a shelf life of 2 years, so there's a lot of canned food, texture vegetable protein, canned vegetables, you name it. We brewed beer, we brewed wine, we did what we could to survive. One of the other added experiments, was Mars time. We actually went on over a month of Mars time that took us 37 sols, or 38 Earth days, where we added 39 minutes to our day, and this was done with the support of our mission ground control team, who helped create a customized watch for us to reset our watches every morning. And it was a really cool experience to go through, and it took about a week. I felt jet lag for every day during the week, getting hungry at the wrong times, but then we all found kind of a natural rhythm, and this actually felt more normal. And we were able to do that with the 24 hours of sunlight by boarding up the windows kind of at the new, okay, this is 7:30 p.m., the windows are being shut. And then we would just have to do our best if we had to go to the downstairs of the habitat, because it was essentially a 2-story tuna can where we were living on the upstairs. So here's us preparing to go out in the field to do our research. The spacesuits are mimicking all the mobility issues that you would have. You're wearing a bulky suit with a backpack, and there's fans within that backpack blowing air into the helmet, so you do have a feeling of air circulation, but it is obviously hard work in them. Wearing big ski gloves, you lose dexterity, and you have the same issues that you would have wearing a fully pressurized suit. In spacesuits, luckily I was able to work on that for a little bit of research as well. Some snapshots, a lot of the ones when there's still snow on the ground here. That drill was our best friend. That was used for majority of our work for geology and biology. For geology, we were able to take cores kind of going deeper and deeper each segment. For biology, though, it got a lot more trickier. We had to sterilize the drill bit before putting it into the ground each time. And so using ethapropanol and a barbecue torch, we had to sterilize it each time. So that was probably new for anyone conducting in a space kind of simulation. So fieldwork, I love this image because it really shows Pat Rawlings' imagery coming to life. Our commander Melissa in the sort of the middle to the right there, and Kathy, our biologist, taking a look at a rock sample. It's not staged at all. This was actually in the field. So you can see the habitat in the background. I was joking, it was staged, but it was for a great photo. Here's drilling into the permafrost. So one of our major studies for biology was looking at the microbes at the permafrost layer. And so during the summer, it got a little bit more trickier. In the winter, we just had to shovel all the snow out of the way, and then the permafrost layer was pretty close to the surface layer. So it was more like this. But in reality, as things were shifting and the permafrost layer was actually lowering, you were digging your own grave just to get to it. We were digging up to 1 meter deep in these spacesuits, and that itself was more than a handful of a task. You can see the crew member in the background here. His helmet's all fogged up because he just spent the last half hour digging a hole. So again, in the lab, this is on the first floor. This is Kathy working on a lab sample, looking at corallman heads that are in these ancient lakes, life that once existed up in the Arctic, and how things have changed over the years. The polygons are a phenomenon here on Earth and in Mars. They're caused by freeze and thaw of water. So you got Earth on the left there and Mars on the right. And so we had a lot of remote station sensors that we were putting into the ground to kind of learn about how the permafrost was moving. And it was really topical because on 777, in the middle of our mission, Phoenix launched to Mars. And obviously this image was later on after arrival, but there it is on the ground looking at polygons. So it really connected with us later on that, the work that we're currently doing is what's being done on Mars. So this is the all-inclusive resort. This is the upstairs. It's the wardrobe, it's the dining room, it's the social room, it's the all of the above room. So we were basically being creative with the furniture that we had, moving it out of the way. And on the back wall there, you can see kind of the doors to the staterooms. This is one of the staterooms. This is the biggest stateroom. This is the commander's room. And basically the rooms are stacked like L-shaped. So the other bed is right above her. And then it would have kind of a straight wall that you can't pass, like even me being petite can't get my shoulders walking straight down these things. So private space was really important for these kind of missions, and having your own kind of flair and colors and items from home really add to that. So another kind of reality is global climate change. This is Thomas Lee Inlet in May. All frozen over. We got there really easily on snowmobiles at the beginning of the mission to check it out. It was kind of like, let's explore the area before we're all suited up. And then by August, it was actually thawed, and this was one of the first times in recorded history of it being thawed with the cracked ice. And although it's fun to hop around on those pieces of mini icebergs and play around after being Martian for 4 months, it really shows the impact that we're having on the Arctic. So another important study, water use. The crew was using 12 liters a day on average compared to 350 in Canada, and it's roughly the same in the US. So we were looking at how we could conserve water and what those best practices might be. So really important for water conservation and learning about what's most important for our survival. the key kind of water uses were actually a shower once a week, and that kind of skewed the numbers higher than up to 12, and when you're in reality it's a lot lower. So FMARS, there it is, about 20 kilometers away in the distance. This is the furthest that we explored in simulation in the spacesuits, just because of safety protocols, being able to check in with the HAB, you needed a line of sight and everything else. So while the photographer was busy taking that shot, I was busy taking this photo. It's always your last photo or your first photo of your vacation that you love best. And this is of my colleague Simon, one of the geologists, looking off into the distance towards FMARS. And so it was a great experience, and it really did feel just like a dream. And so a little bit about the future, before I hand this over to our real astronaut, is that the future in the cosmos starts right here and with you. And so there's experiences out there that you can experience to have your own taste of spaceflight. And so what's out there, where are we going? I don't know, but I know that we all want to explore, and so keep exploring, keep going to these places. And I was just kind of put in a food for thought here. Consider this, that Alpha Centauri, our closest star after the Sun, is 4.367 light years away, which means in about 4 months they're going to see this. And that's the crew on the ISS in 2011 with Cady and Ron Guerin, all wearing Yuri's night t-shirts. I believe Cady actually helped capture the Japanese payload cargo transfer vehicle that had those shirts on board. And that's a great story about how Ron reached out to Yuri's night and wanted to be involved. And he's like, hey, can you send me a t-shirt to wear in space? And of course we jumped on that and like, yeah, absolutely, we'll get you a shirt right away. And then a little bit closer to launch, he's like, hey, do you think you could send 5 more? And so it was in the mail the next day. So just one more slide here. Unfortunately, 11.905 light years away is our closest habitable planet that we know of. And they just saw my first Yuri's night in LA in 2003 at LAX Encounter. So with that, I am going to hand this over. Those are the mission patches from all the missions. Over to Cady. Thank you.